Okay, we're going to take a look at rules of exponents. Now, there is one definition that I want you to make sure that you get in that tends to mess people up pretty good. That's this one that's right here. Okay? Now, you can also add in this idea as well. Is that if you have the following. So make sure you pop this other one in there as well. And what it does, it's kind of the same idea that's here. If I got x to the n, it's 1 over x to the n. Okay. All the negative really does is forces it down into either the numerator or up to the denominator, one or the other. So here I've got 1 over x to the negative n. Well, that's the same as x to the n. But that you should have in your little book so that you've got access to it. So when you're going through doing test quiz, so on and so forth, that you can deal with it. So make sure that goes into your digital book. Give you a moment to make sure that you've got that. Oh no. If you want to hang on to it, use it as reference, that's fine. So that happens when we change books. All right. So let's take a look at some of these, some examples that they've got here. All right. So if I look at the first one they got here, they got 1 over 3 to the negative 2. What I want to do is use the rule. So one of the ways that you can think about this, if it was on the bottom with a negative exponent, it's now going to be on the top with a positive exponent. And I can keep that over 1 if I want to. So that means that what we've got here, 3 squared is what? That's all it is. Now if I take a look at B here, I've got three to the negative 3. Is this in the form of a fraction? The answer is no. Can I make anything into a fraction? Yes, I just put it over 1, right? So if I put this over 1, this kind of helps us set up and see what's going on with it. If it was on the bottom, went to the top and became negative. If it's on the top, it can go to the bottom and become negative. So this just goes to 1 over 3 to the third power. And what's 3 times 3 times 3? 27. So this is just 1 over 27. So the idea here again is make it into a fraction. If the negative exponent is on top, rewrite it on the bottom with a positive exponent. If you got a negative exponent on the bottom, rewrite it with a positive exponent on top. Easy enough. Let's try a couple more. Okay, so let's grab. So, I've got that. Well, this negative is out in front of it. Okay? So, it's just going to stay out in front of it. So this is going to be negative. Negative what? Well, this was 3 to the negative 2. Put that over 1. So now it's going to be equal to, and this negative is out in front yet, still, negative, and then this is going to be 1 over 3 squared. So what's this one going to be equal to? 1/9, but it's got to be a negative 1/9, because that negative was outside of the parentheses, so it stays out in front. Now, if I take a look at the next one over here, here the parentheses are holding that negative in there. So this one is going to be rewritten as negative 3 to the negative 2 all over 1, because the parentheses hold the negative with the number. So now we do just the same thing we had before. We had something on top that was negative, so it's going to go to the bottom. So that means this negative 3 goes down to the bottom, but becomes squared now. And we got 1 on top. Remember, the negative inside a parenthesis stays with it. So this turns out to be 1 over, what's negative 3 squared? Well, what's negative 3 times negative 3? 9. Cool. And that's it. So far, so good? Okay. Alrighty. Let's try one more here. You don't want one more? Okay. Here we go. Now I got all these negatives out there. The question that I've got here, should I go and take these negatives and make them positive right away? No. You know why? Because you've got this exponent up here. Because that exponent means that I got to do something with that parenthesis. So how this one is going to look is I'm going to have negative on the outside, negative 3 to the negative 3 up here, all over 1. So that means this negative is on the outside, so it stays out here. This is going to be 1 over, parenthesis, negative 3 cubed. Okay? So it changed. It went from on top to the bottom. Negative still stays out in front. So I got negative 1 over, what is negative 3 times negative 3 times negative 3? First offhand, I got 3 negatives, so is it going to be positive or negative? Negative. Negative what? 27. So if I got a negative up here and a negative down here, that means it's just 1 over 27. Okay? Now, the problem here, David, is that if you would have done it up here to begin with and did all this, you would have gotten the same exact answer. But you would have done it wrong. Because if that would have been an even number up there and you would have tried it, you would have ended up getting it wrong because it would have made it positive when it should have been negative. So you've got to make sure that you follow that order of operations through. It's just takes practice. So let's see what else we got here to play with. Product rule for exponents. Now this one I know that you guys have done before, so it's not that big of a deal. But we're going to take this one down here. Looks ugly, right? Okay. It's actually a lot easier than it appears. It is. Okay. All I've got to do whenever we're multiplying them together, whenever they're stuck like this, we add the exponents. So, I start off here with y. If I don't have an exponent, what is it? You guys remember what that was? If you don't see an exponent, what number can I put there? 1. So that means there's a 1 that's right up there. Everything else has got an exponent, correct? So, if I look at just the y's, I've got 1 here plus negative 3. What's 1 plus negative 3? Negative 2. Plus I've got a 5 over here. So if I take all those together and I add them up, what do I get? So I had 1 plus negative 3, which is negative 2. Negative 2 plus 5 is 3. So that means y is to the 3rd power up here. Okay. Now, what about x? X is to the 4th. X is to the negative 10. So 4 and negative 10 give me what? Okay, negative 6. It's taking care of at the bottom here. I got a y down there. Negative 6, positive 10 is what? 4. Okay. Now I've got x. I got negative 3 and negative 2, so that's going to be a what? Negative 1. Now, what? Yeah, you're right. That's a positive 2. That's a negative 3. Negative 3 and positive 2 is negative 1. Yeah. Nope. The negative isn't in front of the x, it's in front of the exponent. Okay. So now it's time for some more mental gymnastics here. What? You don't like mental gymnastics? Okay. What we always want here, there's either 2 ways that this gets simplified. Everything in the numerator or everything positive exponents. So if I take a look at what they did for the solution, they went and put, well, they gave us both of them. So I'm going to go through and identify both of them. So what we can do, and actually this is the easiest way to deal with these, is we take each one of these and move them up here. So if I've got x to the negative 1 down here, what would it be up here? X to the what? Positive 1. So it's x to the 1. This y goes up here. So now it's going to be y to the what? Negative 4. It just changes. If I move it from top to bottom, sign changes. Bottom to top, sign changes. So now I'm going to do exactly the same thing that I did over here. So if I've got y to the 3rd, y to the negative 4, I am now going to have y to the what? Okay. If I've got x to the negative 6 and x to the 1st power, I'm going to have x to the what? Negative 5. This is perfectly legal for the answer. However, you will also see the answer written this way. 1 over y x to the 5th. Because here they're in the numerator, here they're in the denominator with the opposite sign. So one or the other. I generally tend to leave them like this because we tend to use things more in the numerator when we're doing algebra. Right? Sort of kind of makes sense? Like I said, it's just a lot of mental gymnastics. You're just moving a lot of stuff around. So, let's see. Okay, let's try this. Now, this one looks flat out ugly. Okay? There's no numbers there, and there's letters, and there's variables in there. So, whenever we have a power to a power, does anybody remember what we do? We've been adding when we just got them all multiplied together. So when I got a power to a power, now we get to so this one here is going to be, if I see I got x to the a to the b, those get multiplied together. So I end up with x ab. Now I've got y. I've got y here, and then I've got this b plus 2 up here. Now, think about it as being a parenthesis because we end up using the distributive property. So this turns out to be a multiplied by b plus 2. All over, what's on the bottom? Well, that's x to the negative a. So that's not that big of a deal. So my question for you is this as simple as it gets? Yeah, there's really not much. You could move the x up there if you chose. Okay? So if I did that, then I would look at, would I be seeing this? X, AB, X minus A, Y, A, parentheses, B plus 2. Is there anything more that I could do with that? Is there? You sure? What about those x's? Could I combine those x's together? Would that work if I combine those x's together? Is that even legal? Well, it is. Because if I have the same base with different exponents, we have a rule for that. These get added together. So this is what it looks like. X, A, B, minus A, Y. If you want, you could distribute it out. AB plus 2A. When it comes to dealing with algebra, you need to understand the rules, not the numbers. What can I do? If the rules say that I'm supposed to multiply, well, then I just multiply. Okay? The rules say add, well, then I just add. Whatever I have there, I just simply add them together. And that's usually a hard thing to understand, is because you guys want to deal with answers. Like I told you previously, it's process. You have to understand the process on how to get there. So, let's see. Oh, yeah. These are eminently fun. Oh, you don't like scientific notation? Now, you guys will be dealing with this more in science than what we do here. But, you know how to write things in scientific notation, right? Okay. Whenever you're dealing with scientific notation, it's always going to be some number multiplied by 10 to some power up here. Now this number here has to be between 1 and 10. Okay? So it's only going to be something between 0. It's not going to be over. It's not going to be 10 and over, because 10 will just get changed into a 1 with a different exponent. So this is going to be 3 times 10 to the what? Well, it's already the -6 power, but I need to move this decimal point so that it goes 1, 2, 3, 4. So I've got to get a number between 1 and 10. So how many places did I move it over? 4. So I moved it over -4. So that means this one here is going to be what? 10. Okay. That's one of them. 4. 4 times 10 to the what? Decimal points back here. 1. Oops, sorry. Decimal point being back here. We end up with 1, 2, 3. You can close the Chromebook. Because if I have to be telling you to be paying attention watching up here, then I'm going to have you log in every day through the secure site, and I'll be keeping an eye on your name up here, and if it isn't there, if I can't trust you, then there's no point. So I moved this one over 1, 2, 3 places. So this is going to be 10 to the third. Positive is for bigger numbers. You're moving decimal numbers around, negative. Right? Kind of an easy way of dealing with it. So here it's going to be 6 times 10. I got a 15 up here. How many places do I move this decimal point? 1, 2, 3. It was a -3. So -3 and 15 gives me 12. Here it's 2 times 10 to the, how many do I got to move it here? 1, 2, 3. Sorry, 3. You're on the right track. So that's going to be 10 to the what? Plus the 4 that was already there. 7. Okay. So now, as we continue through this, now we got to do a little work to this now. I'm going to end up having to take 3 times 4. What's 3 times 4? Okay, I got to quit asking you guys easy questions, right? So that's 12 times 10 to the -7 and a 3. Add them together. What do you get? -4. Not -4. Negative 10 and a 3. -7. That's a -10, positive 3. All over. What's 6 times 2? Last I checked, it was 12 times 10 to the what? Positive 12, positive 7. 19, right? Okay, so here goes the last one. What's 12 over 12? 1. So this is going to be 1 times 10. This goes up here as 10 to the what kind of 19? Negative. So -7, -19, -26. So the answer to that one is 1 times 10 to the -26. But you guys have played with scientific notation before. This is nothing new to you, especially when you get to play with science. So Let that up there for a few moments and let you finish on that. So 14, you guys got 5 minutes here. Okay. What I want to do is let's give this a try. Okay, I'm going to give you a minute, and I want you to do those four. All right, so let's give this a whirl here. Bailey, what'd you get for number or for A? That's because you didn't do it. What did you get? I mean, if you don't want to do it, and you don't want to be here, I'll go and talk to Mr. Johnson. We can make other arrangements for you. After all, you're a senior. You got to pass to graduate. So what do we get? For the interest of time, can anybody help them out? What you got? 8? Okay, so that goes up there negative, so it's just going to be a plain old 8. Absolutely correct. Okay, let's try B. So we've got, Eli, what do we got? Got 16. Would it be 1 over 16? 1 over 16, because we got the negative here, so that means it's going to have to go 1 over 2 to the 4th power. Okay, so watch those negatives. Let's try this. Number 1, Mr. Anderson, what do you got for C? Negative 1 over 4, absolutely correct. The negative stays out in front, and it turns out to be 1 over 2 squared. And let's see, one more here. 6, that gets us. Kaya, what'd you get for D? Okay, so I've got that negative up here, correct? So does that mean I rewrite it like this? 1 over parentheses negative 2 to the 3rd power. Would you agree with that? Okay. So what is 2 times 2 times 2? 2 times 2 is 4, right? Times 2 again is 8. If nothing else, use your graphing calculator for that. So it's going to be, or use your calculator for that, 1 over 8. Now, is this going to be positive or negative? Negative. Well, how many negative signs would there be? There'd be 3 of them, so a negative times a negative is a positive, times another negative gives us negative 1 over 8. So Let's see. Let's try one more. So, give G a try there. Give you a minute or so to work on that. So, David, what did you get as a final answer? What do you have written down for your final answer? You got to write things down. Anybody got an answer? An attempt? Got something, Cole? Mikey, you got something? Give it a shot. Best time to be wrong. What you got, Freddie? X to the fifth, y to the second. Okay, so let's take care of this. Take care of the top first. So I've got an X up here. I've got 1 here, and 6 makes it 7. 7 and negative 11 makes it negative 4. Y is on top. Y to the 8th minus 3 is 5. On the bottom, we have an X. Negative 5, yeah, negative 5, negative 4, negative 9. Yeah, I know I can't. Y. Now I don't have anything there, so it's Y1. So y to the first, y second, that's going to be y cubed. So if I move this up to the top, this is y to the negative 3. If I move this one up, this is x to the 9th. So now I've got my x's. Negative 4, positive 9 is 5. Positive 5, negative 3, y squared. Absolutely correct. So I'll end that there. Tomorrow we can move on to the next stuff. But I got tomorrow is going to be a lab, and we kind of go over a few other things. So there's really not an assignment that you'll have to do with it, but we'll be doing some work in class.